So now we have been saying that we are increasing greenhouse gases, that's trapping more of the thermal energy that should escape to space, but we are preventing it from escaping. So the atmosphere is getting warm, and hence the oceans are also getting warm. Plus, the increasing CO2 in the oceans has an additional impact. It acidifies the waters. If you understand the pH scale, then the pH keeps reducing, and we said that affects the calcifying shell animals negatively. So you have various things, oysters, clams, of course, and corals, and there are many phytoplankton as well which create these shells. And if the corals die, then all the fish that depend on it are going to die as well, and so on, right? And the question then is to look at what happens when ocean water turns warm and acidic. Corals can feel the stress from acidifying waters. They lose their color and they turn white. This is known as a bleaching event. So corals then grow weak and are more likely to die. There is more detail as to why coral has color at all. We said it's a polyp that goes and builds a reef with calcium carbonate or chalk, and that's white. Where do the colors come from? Well, we mentioned symbiosis. Symbiotic algae glom onto the walls of the coral. Symbiosis means I do something for you and you do something for me in return. We are both happy. So the phytoplankton live on the wall and they get nutrients. Like we need minerals and food, they need some nutrients, they need light, and they need oxygen to breathe, or they produce photosynthesis and oxygen and so on. So they take out the CO2 from the coral so the coral itself can breathe. It's an animal, it needs oxygen and it needs to breathe, so they help each other, and then other zooplankton come to eat the phytoplankton, and big small fish come, big fish come, they all have colors and so on and so forth. So this is not in color, but you can go find colorful coral images, and there are many types of corals: warm water corals, cold water corals, and brain coral, and so on and so forth. So if the waters get too warm and acidic, then the algae that live on the corals die away, so the colors disappear and they become white, and that's called a bleaching event, because a bleach is used to clean white clothes, to remove the stains and so on and so forth. So bleaching is that happens to corals. In 2016, the reef experienced a bleaching. It was great loss of life and color, with all its creatures in danger. That's for the Great Barrier Reef. Then it happened again in 2017, 2 years in a row. That was unheard of. Everything was happening faster than expected. So if there are natural bleaching events, there are things like El Nino, which warm the ocean in the tropical Pacific and cool it somewhere else, and so on. So natural events of coral bleaching also happen, but with warming you can increase again the frequency of bleaching. Scientists predicted that by 2050, if CO2 emissions do not slow down, the Great Barrier Reef would have bleaching events every year. Again, would have, because we are not 100% sure. These are projections. When we do weather prediction, we're saying exactly what may happen tomorrow. I say may because again there is a probability of temperature being so much tomorrow and the rainfall being with 30% probability or 60% probability. But here the CO2 is not changing so much from today to tomorrow and so on. But when you go to 2050, CO2 would have changed a lot, population would have changed a lot, renewable energy would have changed a lot. So you have to add some more information from the models to project, not predict, to the year 2050. So reef would have bleaching events every year. The climate is changing, said an expert from the Great Barrier Reef Marine Park Authority. The overall impact of climate change is a major threat to the future of the reef itself. This is the present. So what does the future look like? We will see that in the next chapter. So here is a scary picture of a future coral. It's all dead, bleached, and fish have disappeared. There is only one little fish still looking to see if it can find and see this coral. Looks full of life, things growing on it, and fish are inside and outside, and various other things are happening, but this one is definitely dead. Looks like a famine in the coral reef, a drought, and so on, right? So let me introduce the pH scale, just in case you are not aware. If you're too young and the chemistry is too much, don't worry about it. If you're old enough, you probably already know. So pH is a way to measure how acidic a particular liquid is. Okay, so it's a minus log of the H plus ion. That's the measure of acidity. Okay, so you have scale of 0 here for a very strong acid like hydrochloric acid, HCl. We have chosen 7 here as the scale of water, which is neutral. If you go in this direction and pH increases, like with blood and baking soda and milk of magnesia and ammonia and soap, bleach, drain cleaner, and so on, they are more and more basic. You may know, maybe mom has given you a little bit of baking soda or milk of magnesia when you have a stomach problem and you have a gas problem. She thinks, child, you need some milk of magnesia to reduce that acidity in the stomach. But if you increase acidity in this direction from water to milk or coffee or glass of wine and lime or vinegar, and your own stomach has a lot of acid in it and so on, then the pH keeps on decreasing and HCl is a scale of 0. Okay, obviously these are arbitrary scales, but it's good to remember water is here at neutral, pure water, that is. If you add salt, things change. If you add coffee powder, things change, and so on and so forth, right? So that's the pH scale that you have to be aware. So when you add, it doesn't show here carbonic acid, which is what you get when you dissolve CO2 into the water. The amazing thing is that oceans have maintained a pH of about 8.1 or so for tens of millions of years, because that's how the chemistry, the rain falling on land and coming into the ocean, bringing lots of chemicals and salt and organic matter into the ocean, and the ocean sinks and rises and so on and so forth. So ocean has managed to regulate the amount of CO2 in it. The pH of the ocean somewhere here 8.1, so slightly basic. As you keep increasing CO2 into the atmosphere and CO2 keeps dissolving into the ocean, it's moving towards this direction, and that's not good news for all these corals and the other shells that exist, the calcium carbonate shells. Okay, the other question you ask is, are there heat waves in the ocean as well? We said we are warming the atmosphere by increasing greenhouse gases and trapping the outgoing thermal energy that is not escaping to space but just staying in the atmosphere and warming the atmosphere, warming the land and warming the oceans. If you're warming the ocean, are there heat waves? Yes, they are called heat waves, but remember again that heat waves are anomalies of temperatures from the expected temperature, and then there is a difference. We learned about chronic changes, which means oceans are warming decade after decade. So that's a slow warming, right? That's not a heat wave. Heat wave is something that rapidly warms. There can also be cold waves, by the way, rapid arrival of cool waters. So oceans, some regions are warming rapidly enough to be called heat waves, and heat waves of course affect what is dissolved in the ocean, like the CO2 or the oxygen, affects the ability of the water to hold these gases. Remember, a Coke can is kept cold because you want the CO2 to remain inside. If you keep it warm, it can come out, and so on. So oceans do have heat waves. It needs some definition of how much it has to warm, how fast it has to warm, and you have already learned that the ocean has very high heat capacity, which means to warm it by 1 degree, you need to put in lots of energy into the ocean, whereas on land, which has a low heat capacity, it can warm up very fast, right? During the day when the sun comes up, the land warms very fast, and at night when the sun goes down, the land cools very fast. But the oceans do not warm up so fast and cool down so fast, which means for having heat waves, you have to warm the oceans very rapidly, and that requires a lot of energy as well. So now, just like on land, we have heat waves and cold waves and warnings of heat waves. In the ocean, people are beginning to make forecasts of heat waves. They're called marine heat waves, or MHW. If you see MHW somewhere, you say, I know what that is. That is a marine heat wave. Now we talked about heat wave on land in St. Louis, Missouri, and we said if the heat wave lasts 40 days, what are we going to do about the crops? How are we going to protect them? It's the same thing in the ocean. If a coral is sitting there and a heat wave is coming, so the Great Barrier Reef is right here off of Australia in the warm Pacific Ocean, and if you are getting a heat wave here, as you can see, the darker colors are stronger heat waves than here, and you can see that the cold Arctic has had many heat waves recently, and I'm not showing the date here, but this is for a particular period. And NOAA, the National Oceanic and Atmospheric Administration of the US, and European agencies, they're all Australian agencies, they're all issuing marine heat wave warning. But what are we going to do with these warnings? If there is big school of fish and a heat wave is coming, can we go and tell the fish, hey, move on, there's a heat wave coming? The coral cannot even move, it is stuck to the ground, so what are we going to do? But it's still useful to have this information to see if we can say next few weeks there is going to be a heat wave in the Great Barrier Reef. We can send people, we can send drones and planes and boats to say, please watch what's happening. How do corals respond to heat waves? Are they going to die, or do they have a way to fight the heat waves? What happens if the heat waves get more frequent, last longer, get larger in scale, and so on? What are we going to do about the marine heat waves? So that's the idea, that there are marine heat waves, and this is again showing for April 24, 2024 to May 23rd, 2024, past 30 days of marine heat wave magnitude in degrees centigrade. So you can see some heat waves here that are strong, some here, some that are not so strong, but they are still damaging again the Great Barrier Reef here and the Bay of Bengal or Arabian Sea, and there are reefs, coral reefs here in the Indonesian. In fact, this region is known as the Coral Triangle because the temperatures are warm and corals like to grow in warm temperatures, other than the cold corals which grow in cold waters. Okay, so yes, marine heat waves exist. Yes, we are observing them and trying to see what they are doing to the things living in the ocean, as well as to things like CO2 and oxygen, because if warm waters begin to release oxygen instead of keeping it dissolved, then what happens to the fish that are living there, what happens to the corals that are living there, and so on and so forth. So that's called deoxygenation, where oxygen is reduced in the water. So you have acidification, where CO2 is dissolving and making waters more acidic and reduce the pH, and you have deoxygenation. Okay, some fish run away if they can, some fish die, and so on and so forth. So these are the problems, these are the troubles at sea based on our own activities that are increasing the greenhouse gases and warming the atmosphere and acidifying the ocean waters. And remember, sea levels are also rising. If sea levels rise and the corals submerge into the water, then they can die as well. So because they don't get enough light, and the phytoplankton that need the light to do the photosynthesis sitting on the corals cannot do photosynthesis, which means The fish die, the CO2 increases, coral can die, and so on and so forth. Okay, so let's leave this here, and this chapter is finished. Now we come to the last chapter called the present climate and the future climate. We have looked at the past climates and said climate has always changed, and now we are saying present climate is changing, and we are perturbing the natural climate variability. Then we want to know where are we headed into the future, and that is your future because you are young. You have to worry about it. So come back and listen to a bit about past climates we learned about. Now we talk about present climate and future climate. We already said how future climate is projected, so we'll look at some of that. Okay, see you in the next and last chapter of this book. What is climate change?